Now we're moving on to example number 3 of finding domains and ranges of functions using graphs. So now we have this weird looking function here that's basically drawn with arrows going all the way up here to this dashed line and then down forever. And then we have this one going down forever but never crossing over this dashed line. So this dashed line here indicates that we don't cross it with either part of these graph segments here. This will go up forever, but it'll never cross through this line. All right, so that's what we call an asymptote, or a vertical asymptote in this case. This arrow will go forever. It'll just keep going up in this general trajectory. It'll just go up forever. This will keep going down forever, but it'll never cross the dotted line. So if you like, you can extend your dotted line to say, hey, look, it's never going to cross it. All right, so the first question we need to ask ourselves before finding domains and ranges is this graph, or does this graph represent a function? Does every x value, any x value that I plug into this, give me exactly one y value? So it's going to be kind of hard to see in this case because we have so much going on. So, but if I plug in, say, 2, 3, 4, 5, 6, do I get exactly one y value out for that? Does the graph turn back on itself? Okay, if the graph turns back on itself, then it's not a function. The graph does not turn back on itself like the letter S at all. So this is a function. Yes, it's weird looking, but for every x value that I plug in, I will get exactly one y value. So it's a function, all right? The domain is the set of all x values that I can plug in here. So here's the concrete way of finding the domain. Just like in the last video for the range, I scanned up going horizontally. I'm going to scan vertically starting over here, reading left to right. So where does the graph start? Well, there's really no technical starting point, but we could quote unquote say infinity. Okay? Because this arrow means it's going to keep going forever in this general direction. So it starts quote unquote at minus infinity. So I scan left to right, started in minus infinity, continuing along. I'm still touching the graph, still touching the graph, still touching the graph. Where do I stop touching the graph? Ooh, right here at this x equals 1. I can't plug in x equals 1 because the graph never touches it. I'm never going to get a y value out for it because this is just going to keep going up forever but never cross at x equals 1. This will never cross at x equals 1 either. It's just going to keep going down forever, getting closer and closer. Okay, so I read from left to right, I can plug in, I can plug in everything, up. Okay, I got to x equals 1. So far, we have our domain is from minus infinity to 1. But that's not all of it. I got stopped at 1, that's why I put the round brace. That means I can't plug in 1. But then I can pick up immediately after 1 and then keep scanning because now I'm touching the graph again. All right, so I stopped here at 1, I can keep scanning to the right. My graph is still touching my vertical line, and therefore I can continue by writing union 1 to infinity. So basically, I started at minus infinity, quote unquote, starting at minus infinity. I went to 1, stopped. The union says, okay, I'm going to pick up again at 1 and go to infinity. Okay, stopped at 1, picked up at 1, and then go to infinity. But notice that I have the round braces. That means I cannot plug in 1. So the domain is everything. I can plug in any x value I like except for 1. These are the set of all x values I can plug into my function and get a y value. So range. Scanning from bottom to top, where do I start touching the graph? This one keeps going down forever. So I start touching the graph at y, well, at minus infinity, if you like, okay? So start at minus infinity. I'm still touching. Do I stop touching at any point in time? I'm always touching this graph. Still always touching. I never stopped touching this graph. So since I never stopped touching, I just write infinity. So the range is everything. I hit all possible y values but I can't plug in 1. So the domain is minus infinity to 1, starting at 1, going to infinity, and the range is everything. All right, so we found the domain, we found the range, and we've concluded our example of this weird asymptote case. Okay, hopefully you found this helpful. We'll be doing even more examples in examples 4 and 5. Hope to see you there at projectgradered.com. Links in the description.